All right, the time now is 5:41 p.m. Today is day 4 of the Blind 75 grind. So today we'll be going through the longest repeating character replacement. So this is a very interesting question, but it tests the fundamental of arrays, hash maps. So if you look at the topics involved, there will be hash table, string, sliding window. So I think this is quite important because uh, you get to see the most. I think there's a chance you can structure all the data that you want to be the most frequent and then package them together and send it over the network, something like that. Well, I'm just trying to make some applications to whatever I'm doing in LeetCode. Okay, so without further ado, let's get started. You are given a string S consisting of only uppercase English letters and an integer k. You can choose up to k characters of the string and replace them with any other uppercase English character. After performing at most k replacements, return the length of the longest substring which contains only one distinct character. So for this question, I think the most important part is, apart from all this, is that you don't need to actually change the string. You just need to, you don't need to even say which index you are changing. You just need to say the longest length. So that means there's actually no need to change. It is just all soft replacement. So actually, I tried the question before that and I couldn't really get that far. Kept getting stuck on a few cases. So I took a look at the hints. So we'll go through this. So the recommended time and space complexity will be ON time, which is one pass on the string, and OM space, where M is actually the number of unique characters in the string. So there's a chance that this is related to the hash table, while this is related to the string, and the sliding window causes it to stay in the string. Yeah. So I think we need to write down some considerations. So edge cases wise, S, I mean, if S is equals to S dot length is equals to K, or S dot length is equals to 1. So if S dot length is equals to K, or S dot length equals to 1. So we can just return S dot length in this case. So let's move on to the meat and potatoes. Since I went through the hints and I've tried this question out beforehand, I was quite busy with work, got a bit disrupted, so I couldn't really internalize the hints and get it done. So which characters will you replace in a string to make all its characters identical? Can you think with respect to the frequency? So there's a hint that says you have to use a hash table. So we'll initiate a hash table. Okay. So next hint. We will try to replace the character that is the most frequent, right? No doubt we have to do one pass to go through all the characters, but all the characters we should only replace the most frequent character. Okay, it's always optimal to replace characters with the most frequent character. Yeah, most frequent minimizes number of replacements needed. So actually with this, right, how can you find the number of replacements now? It's actually equals to let. Uh, we always need a left, right. So in this case, right shouldn't be 1 because you need to write a comment. Right cannot be 1 because you might replace first character. So this is because there was a case where it's something like A, B, 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 and you can replace 2 characters. So the output was 3 instead of 4. Because by right, instead of replacing B, right? Instead of replacing A, I want to replace B, which caused the count to be A, B instead of replacing the first character. So we start with right equals to 0. So learn from my mistakes. Then next, we need to have a let longest count is equals to 0. So this one tracks the count of the most, or rather tracks the highest frequency character. So later you will see why, because you see, using the most frequent character minimizes the number of replacements. So we can make up to k replacements, right? So we will look at a substring. So look at substring. So this is left, right. So by default, substring is empty because there's no characters. Then we will expand it and then we will check. We will store it inside the. So store the frequency in a map and increment it along the path. Okay, so this is the crucial point. So we look at the next hint. So how can you find the number of replacements now? So we want to find the number of characters. So let's say I have a string, right? I do left to right. This is actually equals to right minus left plus 1. Thanks. Okay, so maybe this is not a crucial point. This is just the window size. Okay, then for next one, if let's say the window size plus if the window size is smaller than so you need to compare this to k, right? So the longest count, highest frequency character, right? How does it relate to the window size? So we need to take the longest count. Let's say you have using the example of A, B, A, B, B, right? So in this case, right, we can, if let's say we can do k equals to 1, output is 4. We will want to replace second A when looking at window of EA. So the first A is out, we want to replace the second A, and then we'll get 4, right? So the longest count, right, which is in this case will be 3, right, plus k must be more than or equals to the window size, right? So in this case, we can just write y minus left plus 1. So in the event that the longest count, the most frequent one, so if it becomes less, this means that the window condition is violated. Okay, so maybe we break it down in the next line. If it becomes less, that means that even if you replace k characters in the window, the longest count, it will not mean the whole window is a substring and be broken in the middle. So this is the crucial point, right? So I'm going to put a star here. So what do we do now? We write. So we have to pass through the whole place, right? So we do our right, or rather we can just do let I equals to 0, I less than s dot length plus I, and we'll do first of all what we want to do, right? We want to store the frequency, the map, and increment it along the path. So count map dot. So let's check. Const current L is equals to s dot I. So const current L count is equals to on map dot get as current L, or is equal to 0 because it may not exist. So count map dot set, right? We want to do the set the current element to the key value. The value should be the current L count plus 1. So basically increment the counter, the R counter. All right. So far so good. So the next step, right? What I want to do, right, is to check. So we will do let longest. So longest count will be equals to count map dot get the current element, and then we want the math dot max longest count. So in the event that longest count, I have another character that is longer than the current character, I don't change it. I'll just set this as a maximum count, right? And then I will do wow. So this is the crucial part. So what this means is that the longest count is equals to the maximum of the longest count, or maybe if this character has a longer count, I will set that as the longest count because now this character is considered as part of the window. And then there's a crucial point. All right, turns out I wasn't recording just now, and because I had to pause to do some work. So turns out I managed to solve this problem. And I think we stopped here at the crucial point. If the window condition fails for the current character, meaning let's say the current character is in this case, we do let's explain this. So the longest counter so far is three. Is 2, right? Because you only count the frequency of the character. So let's assume that left at the start. So I changed a few things. There's no more left and right. It's the start and the iterator. So the iterator will function as the right in this case. So if let's say the longest count of in this window, right, substring, right, is 2 plus k is 1, and then I is at 3. 3 minus 0 plus 1 is 4. 4 is greater than 3. So what do we do? Yeah, so we have to shrink the window because right now I have 4 characters, and if I were to replace one of these characters, right, it makes it such that the longest substring is no longer bigger than the window or equal to the window. So the limit is when the substring is equal to the entire window. That's when you know that all non max frequency characters are changed. So start element will move it to the right. If not, we need to remove this A and sort of shift it to BAB, just BAB. So what do? I do start element count. I mean, obviously there'll be something, right? And then I'll just do start element count minus 1, because right now there's going to be one less A in the hash map. And then our increment start. So why did I use a while loop rather than an if, right? Because you will think that, the moment this breaks, right, I will shift it by one character and the window size will shrink. But that is assuming that the character that you're shifting to is also the same character that came from before, which in this case, it will never be the case because there's no reason why you would shift it if the count is going to be included in the window count, right? So if the window condition fails for the current character, it may not fulfill for the next character in line. So we must keep looping. And then we will continue looping this window condition, which states that if it becomes less, even if you replace k characters in this window, it will not be the whole window as a substring. So we are just trying to find the window size where all characters are the same. All right. So next iteration, we will do BAB. And then the thing is, at this point, right, we will set the result as res, the current res, which is 3, A, B is, if let's say it's this window, right, it's 3, and the longest count will be longest count plus k, right? So at this point, the longest count is actually equals to 2, or rather it's not equals to, so we close the window, right, it will become like this, and then at this point, longest count is actually equals to the longest count of the current count plus the map. So assuming the window shifted here, the longest count will remain the same, which is 2, right? So in this case, we do longest count plus k, which is the window size in theory, and then we compare to res. Is it still bigger? So there's a chance that when you reduce the so-called window size, right, the longest count plus k will be smaller. So you might have to stick to res. Okay, so longest count plus k. Okay, sorry about that. So at this point, your longest count is we'll just count it up. Console.log longest count. Longest count will be 1. And then when you jump to y, you will take x. So longest count and let's say k, because k never really changes, right? So in this case, you will get 1 plus 2, 1 plus 2 when you're at y, because the window size will increase from x to xy. So let's just use the other example. So we'll just iterate through. So we'll look at x first, add it to the map, and then the longest count will be 1, because that's the only character. Okay, and then longest count 1 plus 2, then your I will be 0 minus 0 plus 1. So 3 is not smaller than 1. So we skip this, and then we will set the result to be the result, the current result is 0, and then the longest count plus k is 3. Okay, so next round, I is equals to 1 now. So I is equals to 1, we'll look at y. So when y is being looked at, it doesn't exist in the map yet, we will just set it to 1. So longest count is equals to the longest count, which is still 1, because remember previously we had 1 for counting x. Now we're looking at y, it is still 1. And then the count map will be, we will get it from the count of y, which is 1 as well. So longest count is still 1, 1 and k, 1 and 2. Okay, so 1 plus 2 is 3. 3, you have 1 minus 0 plus 1, 2. 3 is less than 2. It's not less than 2, so we don't care about this. And then we set the res is equals to maximum of res, which was previously 3, and this is currently still 3. All right, so now we'll expand the window to x, y, y. So current character is y, right? The current count of the character is 1. And then we're going to be adding 1 to it, so it becomes 2. Okay, so longest count will be equals to 1 versus 2, which means that now longest count is 2, because within this window, the longest count is 2. Okay, and then now we just take console log of longest count 2 plus k 2. All right, so longest count plus k is now 4, right? Because now I can replace up to, my longest count is 2, and then I can replace up to 2 characters. So I'll get 4 total y's if I were to do maximum number of replacements. And I is now 2. The start is now 0. 2 plus 1 is 3. So 3 is not greater than 4. We skip this. Once again, we update the result. Previously was 3, right? Now it's 2 plus 2, which is 4. So now res is 4. Okay? So we'll just console.log res and we'll see this. Okay, so now the result is 4. Okay, now the next round, when I is equals to 3. Okay, so means X, so this is the final round. What I want to do is that current element is X. Okay, so this is just a sanity check. You will see that if we were to do this case, we will get back 4 again. All right, so now we look at another case. All right, for this, I think the most interesting one maybe will be this. So we'll look at this case because it's a bit more interesting. So we have A, B, C, D, Z, Z, and K is equals to 3. So at index 1, right, we are currently looking at A. A is nothing, we'll count it as 1. So now the map stores 1 to A. And then I can replace up to 3 characters. So the longest substring that I can have now is 4. So I have 4 here. Next character. So now we see longest count 1 plus 3 is 4. And now I is at 0, start at 0, 1. 4 is not greater than 1. We don't enter the loop. And then we will do the result is equals to 4. Okay, next character, B. So at B, right, what we will do is look at B in its entirety. We count the longest count, which is also equals to 1. So we get 1 and 3, and then we get 4. Okay, result is still 4. So now we look at C. C is also unique, D is also unique, so we skip those. So now we look at Z. Z, this is the first time it's not unique, right? So now I've grown the window size to all the way to 4, right? So what happens now? Okay, so at 4, we will, so now we skip this all the way until here. So we'll now look at this from this onwards, okay? So now, when we're looking at Z, Z doesn't exist, so we count as 4. So now we have longest count is equals to 1, K is equals to 4, and 3. So we get 4, then I is equals to 4, because Z is actually index 4. 4 minus 0 plus 1, 5. So we will have to close the window now, because if let's say I don't include Z, I cannot replace B, C, D. I cannot replace A, so I have to close the window down. So we will actually run a console.log closing window, right? So at this point, you will see, yes, after I get 1 and 3 for Z, I will close the window down, and then the total size will be 4. So now my start element will be 1. All right. Then the result will be the current existing result, because if let's say the longest substring exists way before I close the window, like in the first few elements, right, I want to keep that result. The longest count right now is still 1 plus K, because 1Z and 3 replacement, so it's still 4. Okay, so we go to the next round, index 5. So now at index 5, 0, 1, 2, 3, 4, 5, the second Z, we will look at this part. So now I'll get the count is equals to 2, right? So the longest count is equals to 2 so far, because previously we only have unique characters. So now it's the first non-unique character, the longest count will be equals to 2. Okay, longest count is 2, K can still replace 3. So 2 plus 3, right, is the new so-called largest window size, because if we were to include these two Zs, we can still replace 3. So 2 plus 3 is it greater than index 5 minus the left window, which is 1 plus 1. So 5 is not less than 5. So we skip this, and then we will do the maximum, which is 5. All right. And then we go to the next round. We look at index 6, which is the last character. So last character, we'll get back longest count is 3, because Z is the most high frequency character now. Okay. So every single round, right, longest count will be the longest count of the current character that we are currently looking at, which means that the current right boundary, which is Z, how many preceding characters does it have before that? This will form the window. So this one is, we can't refute this. That's why the longest count doesn't really get changed in this loop or the loop before that, because it's always right towards the right. And of course, if it's towards the right and there's multiple right, so in this case, there's 3, I can still replace the 3 before that, right? So I can maybe write down a note here. Longest count is always towards the right, the hand thing. So I can still change 3 characters at that point. So right now we can see that longest count is 3 because there's 3 Zs in this substring. And then we haven't changed start at all, right? Because they are the same character. So the longest count plus k is actually what forms the foundation of this. Because this loop, if you don't have this idea, the whole question cannot be solved. So 3 plus 3 is 6, and then we'll find this. So the reason why math minimum this is because in this case, where you don't need to replace anything, you will get 6, which is more than a string length. So this is just a precaution. And then remove this, and then I'll submit it again and see how it goes. Okay, good. So let's try it again. Okay, great. Perfect. So let's do another question. Time now is 6:40. I'll go and eat some dinner and then I'll do my next question. All right, hello. So the time now is 7:28. I just finished my dinner. I will try to complete one more medium before 9 p.m. and go through the explanation behind it. So previously, before this question and before I ate dinner, I completed the longest repeating character replacement question. So that was quite eye-opening, and frankly, it was quite a good practice for sliding window. So now we are back to rotating arrays, which means that the end of the array will now become the start and then become like that. So basically, this array has been rotated 4 times because you can see that the first 4 characters are originally the last 4 characters. So you're given an array of length n, which was originally sorted in ascending order. Yeah. And it is now been rotated between 1 and n times, meaning if it's rotated n times, it's the same array, right? So this is rotated 4 times. This can be rotated 6 or 0 times. Given it's between 1 and n, so it can be 0. So given a rotated sorted array nums and an integer target, okay, so sorry about that. Had to take a break to go and do some work. Okay, given a rotated sorted array nums and an integer target, return the index of the target within nums or -1 if not present. Okay, let's say I want target is 1, all right, and you may assume all elements are unique, okay, and it is a sorted array. So previously, for example, I like to jump around 0, 1, 2, 3, there's no 4, it jumps to 5 and 6. It was previously sorted and it is now rotated 3 times, I would assume. Yeah. A solution that runs in O n time is trivial. Can you do an algorithm in O log n time? So this is actually a very big hint already. So trivial because any search in an array is trivial. Even a linked list, right? O n time is trivial. So when dealing with sorted arrays, one thing I learned is you have to create a helper function, right? So the moment you find that, okay, if I take a look at the middle 3 elements, right? For example, right now the length is maybe I'll just write it out. Is sorted. Right. So it's sorted. We will take the left, middle, right. So it's sorted just means return. Left is smaller than middle, and middle is smaller than right. So since they're unique, it is a strict smaller than. All right. So why do I have this? This is very important because you can find the point of rotation at this level, right? And of course, if let's say, for example, I want to find 1. So for example, the length is 1, 2, 3, 4, 5, 6, and 6 divided by 3 is index 3. I'll take a look at this. So 5 and 1, right? It is not sorted. I know that for sure that one of my targets is either on the right side or on the left side, right? So you can start to split the array once you are aware of I mean, this binary search, right? Cutting it in the middle and looking at the left and right doesn't make sense because in this case, one is actually on the right side. So by finding the sorted value, this is where you can actually start commence the search, right? So for this one, if I'm looking for 4, right? So if let's say I take a look at the middle 3 elements again, 0, 6, 0, 1, I know that it's been rotated here, right? So with this, I can make a decision whether to go left or go right, right? So take a look, binary search. Okay, let's look at the hint. A brute force solution will be hinting a better way, right? Binary search. The array is rotated after sorting. Elements from the right end are moved to the left one by one, creating 2 sorted segments separated by a deflection. So the deflection is what I told you. It could be detected by this is sorted. And for example, 3, 4, 1, 2, you can find the 2 sorted segments. So the good thing about this hint is it actually gives a lot of data because you know that the largest value is actually just right before you, right? So if let's say I take a look at these 3 elements, right, and I find out that 4 is not here, do I go to the right knowing that 6 has been brought over to my left? Mm. So in this case, it's pretty trivial because you already have the target here. So if you look at this hint, right, in a fully sorted array, it's easy to find a target. So if you can identify the deflection point, you can cut it and then perform regular binary search, right? So first of all, I need to find the deflection point. So I'll write another solution is so for this function, we will just write if we will do the cut. Okay, so let's cut. Okay, maybe for this, I'll do if no right, I will return left less than middle. If no left, return middle less than right. Yes, so it's pretty straightforward way of doing it. And then the deflection point. So I'll do forms middle index is equals to nums dot length divided by 2, and then I floor it. Okay. So after I get the middle index, I will find the left and the right of it. Okay. So const left index is equals to middle index minus 1. And course, I need to minus 1 greater than 0. Else, then we'll do middle index minus 1. Else, we do big on right index is same. Goes to middle index plus 1 greater than nums dot length minus 1. Then we'll do if it's greater, if it's less than, we will just do middle index plus 1 or 1. So now we just do if it's not sorted. But if it's sorted, we can't really do anything, right? Because We haven't reached the deflection point yet. So we'll do left index, middle index, right index. So if it's sorted, we can't do anything. We have to split. So we will return. So if it's not sorted, right, we'll return the middle index. So then we return line reflection point. So we have to check if the middle index is, if num's middle index is, let's say, for example, greater than the middle index itself. Oh wait, I can't do that because it may not be the. Okay, let's take a look at the next hint. Perform binary search. So we perform a binary search on the array with pointers left and right, which belong to two different sorted segments. For example, in 3, 4, 5, 6, 1, 2, 3. Wait, this is wrong. You can't, they're unique, right? Okay. All right, so I actually take a look at the fourth hint. So if let's say it's sorted, how do you know whether you go left or right? You have to check. So const left L is equals to nums left next const middle L is equals to nums middle index, then const right L is equals to nums right index. So we compare middle to left and right. I think at this point, after you read all the four hints, right, you gotta get it right because they really do give quite a lot of information. So hopefully I remember everything after I implement. So if left L is less than middle L, then in this case, mask deflection is the right side because left side is sorted. Then else left side. So we just do this dot find one, this dot find deflection point for nums dot slice. So left side is the left index. Okay, so I do L and R above there. L to middle X. Else this one return this dot find deflection point. Dot slice middle index should be slicer to R. So at this stage, I think we can just take nums. So supposed to this find deflection point 0 and nums dot length -1. We will console.log deflection point index, see where we get, if this even works. This sorted. If this dot is sorted, so the deflection point is 0. That's not right. So let's check. So left L, middle L, right L. Okay. Five, 6, 1. So wait, how is it sorted? Left is smaller than middle. Hold up, this is not sorted. Oh my god. I need to, oh my days. I gotta put it like outside. I am dumb. Okay, so put it here. Then we need to do L. Right, so I'm gonna remove this. So I think it should return the correct value. So this should be index 3 is the deflection point. In this case, index 3 is the deflection point. All right, so middle index is index 3. Not sorted. In this case, do I want it to be this number, the biggest number, or this number, the smallest number? So we want to return the biggest number, right? The index of, so in this case, it's been rotated 4 times. So index of the smallest number will actually be indicative of how many, okay, return index of smallest number, indicative of how many times rotated, I believe. To be honest, doesn't really matter. So if which then I will do a left switch dot left dot max there, L L case of case left L, then we will earn left index is middle L, earn right index, then is right L, earn on my days right index. Then we do default turn 0. Okay, so let's run. Oh wait, I need to do min, not max. Oh, actually worked. Wow. So this will be 3, correct? Index 3, this will be index 4. Okay, good. Good. So the deflection point index is actually the index of the smallest number, which is equals to number of times rotated. Not sure if important, rotated. So now what I want to do, right, is do a search now. So if let's say the base case, right, if nums deflection point index is equivalent to target, we will return deflection point index. Yeah, this is straightforward. Next, if nums if nums deflection point index is, for example, in this case, my target is 1, I will get 1. So if I run this, I think I should get it correct. One case will be correct. So in this case, I'm looking for 4. So at this index, I need to check the largest number before me. So if let's say the nums deflection index is smaller than target, what do I do? Check if the largest number is there. So const largest is equals to nums deflection point index is 1. Right. So our console.log largest. So in this case, largest is 6. So if let's say largest is bigger than target, if let's say largest is smaller than the target, then we will return -1. Yep, cannot find it. Large, straightforward. Then we'll do the other case. Const okay, else, right? So now we do the edge case is done. So we'll just do, in the event that largest is bigger than target, perform binary search of sub-array on the left side. Else, so in this case, right, we have to do the opposite. Check if smallest number is there. Const smallest is equals to nums deflection point index plus 1. Sorry. So if the other event is nums deflection point is bigger than target, right? We can just return minus, because the deflection point is the smallest number. We can just return -1. Right? Because if nums deflection point, if the smallest nums deflection point index is greater than target, cannot be found. So we just need to really perform the binary search. Yeah. So oh wait, hold up. I can't do this because nums deflection point is always going to be the smallest. Right. Okay, hold on. So I'll do this first because it doesn't make sense. Hold up. Let me just check. So And this deflection point index, right? It is the smallest number ever. So in this case, 1 is the smallest number. We return 1 is correct. So now we have numbers that are bigger than 0 everywhere. Right. So the largest number will be the one before it. So if let's say the largest number is smaller than target, we can't return it. Else, we check left side. So else, we do binary search. So else, check if leftmost, if target is found in left to deflection point -1, else deflection point to right, or rather nums dot length, right? So I need to create a binary search function. So I just do a binary search, nums left, right. So binary search is pretty simple to code. So because now we straightforward. Now both arrays before and after are all sorted. Oops, sorted. So what we do is we do binary search on nums. We do if, sorry, we need to find the target as well. If, so const middle is equals to math.floor r minus l, okay, r minus l divided by 2. Then if left, so if middle, if nums middle is equivalent to target, return middle, right? Else, I will search left. If nums, because I search left because it's already sorted. So this is the crucial part. So this hint. Now you split it down the. So basically the pseudocode. Find deflection point, splitting down the smallest number, and by do normal binary search. If nums target, sorry, if nums middle is greater than target, we will return this dot binary search on the left side. So the nums dot size left to middle, left to middle, and next one will be left. I don't know you know that. Let's do nums, L, middle, target. Else return this dot binary search, nums, middle, R, target. Okay, so find the nums middle is bigger than your target, you find it left side, and this find it right side. Okay, so I need another case where you can't find a target. So if L equals R, then return -1. Okay. Now arrays before after. Check if target is found within here or here. So const leftmost L is supposed to const 0 Okay, so now we have this, we just need to check uh, if target is is bigger than leftmost element, and then I will do this dot binary search nums. Left is 0, right is deflection point x, and then target else is dot binary search deflection point x target. Um, so I run this. Maximum call stack size exceeded. Let me try. Okay, so I think might want to check out what's going on. I think the idea is correct. So target is greater, so we do a binary search, right? Okay, so I'll do console.log middle. I'll see if I can even print out anything. Ah, okay. Okay, so right now the middle is always 0. So if it's not equals to target, we won't do this. If L, so maybe I'll check what L is, right? So I'll check log L, so we get 0, 2, 0, 1. So 0 to 2, then after I cannot find, then I'll do 0 to 1. To 1. So if L minus R is equals to, sorry, if R minus L is equals to 1, we will check if, so in the event that there's only two numbers, right, we don't do binary search anymore. Oh, hold on, I think I can keep that. Goes to R, I will do binary search minus 1. All right. So, all right, maximum power stack exceeded. Okay, so we'll do 3. So the middle is 3. So we're looking for 0. But this is weird. does not make sense. Okay, I'll get to that later. 0 is clearly here. Maybe the deflection point is wrong. So let's console.log deflection point index. Oh, hold on. Let me use this test case. Run. My deflection point is at 0, which I think so I think there's 1, 2, 3, 4, 5, 6, 7. 7 divided by 2 is 3. 3, index 3 is 7. So I look at 6. So what do I want to do? So console.log left L, right L, middle, sorry, right L. Okay. Get 6, 7, 0. So how is this not sorted? Ah, okay. So I can't do this. I'll do it right equals to now. Equals to undefined. I don't think I ever set now. I'll set undefined. 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 If left is equal to undefined. Undefined. Then because it's a 0, and then I don't think there's a need to do a std log and try and submit again. Okay. So let's use this test case. Then we'll run, and then you'll say that, okay, good, the index is correct. So what happened here? The target is 3, and 3 is bigger than, let's see, the largest element here. So if the largest element, which is 7, is bigger than target, we continue. So if it's smaller than 7, it's not smaller than 3. So we continue. So leftmost element. So we find the leftmost element is 4. If the leftmost element is so in this case, target is smaller than the largest but bigger than the leftmost element, then we'll search there. Else we will search to the right. So I believe the right side I have not so-called done a search yet. So let's take a look. So in this case, we'll console.log. We will console.log middle plus 1. This case, all right, there's a lot of this one is even worse. So I think this is an edge case that we forgot to account for. This is number 6. So if nums dot length, so we need to look at the question again. Nums dot length is equals to 1. Then I will check, and nums 0 is not equals to target. We will, wait, I can do this, equals to 1, and if return nums 0 is equal to target, then if it is, I will just return 0, else I'll return -1. 7. Okay, this is crazy, man. So many edge cases. So this question is very good for finding out edge cases. So far, let me just write down the edge cases. So binary search off by 1 on both sides, causing maximum call stack overflow. Okay, 2. Nums dot length is equals to 1. Okay, 3. So in this case, right, what will happen? Right. So the deflection point, console.log. I'm very curious to find out what the deflection point is for this. So console.log deflection point index. STD out is 0. So there is no deflection point. Right. So what I'll do is I will take the largest. So this is by right. I take the largest number, which is deflection point -1. Right. So I need to handle this case. So if so if let's say, so this is another edge case where rotated max times 2 times nums dot length times, so get back the same sorted array. So this is another edge case. So if deflection point index is equals to 0, then we will do nums. We will do the largest is actually equals to nums length nums dot length 1, or this. So in this event, if the largest is 3, it's bigger than target, smaller than target, return -1. So now I have to search. So actually, I'll do this equals to 0. Then I'll do the deflection point is equals to 0 means there is maximum number. So I need to nums dot length. Then I'll just do this first. Okay. So deflection point index, I got it. Then if it's equals to 0, so I'll just do false deflection. Sorry. So just do a const corrected DPI is equals to deflection point index is equal to 0. Then we will set it at nums of length, else we use deflection point index corrected DPI equals target, and we return corrected DPI, then corrected DPI. Okay, we just do corrected DPI. Oh wait, sorry, what's this? So largest is if deflection point index is equals to 0, then I'll use the corrected DPI, else I'll use this. Okay, good. If target is bigger than the leftmost element, if not, I will do this. So I'm searching from DPI, which is to oh my. Okay. There has to be a more elegant way to do this. Oh, wait, if corrected DPI is equals to nums length, I can just do binary search on the whole thing. Yeah, okay. Oh man, I need to undo everything. Okay, let me just run binary search on the whole thing. Seems sorted. Let's do a binary search on the array. So, right. So else if deflection point index is equivalent to 0, just return this dot binary search nums 0 nums dot length -1. Okay, this case so binary search, let's see, console.log L R, right? Hmm. L is greater than R. So instead of this, I'll just do greater than equals to R, submit. Number 10. Okay, I'm getting back this again. So in this case, why is it returning this? Right, so console.log L R. Okay, wait, let me submit and get a test case again. And I get -1. I get 0, 1, 1, 1. So 1 minus 1 divided by 2 is 0. So wait a minute. One minus 0. Right. By right, this solution should just indicate. Okay, right is 1. Left is 0. So R minus L is 1. Divided by 2, I get 0. So nums is not. So nums middle greater than target. I think I have to slice it. Middle -1. Right. Or I do nums dot slice middle +1 or run that. Okay. So dot log. Check. Okay. So 1 and 3, by right, the target should be either one of those. So yeah, I think this is still wrong. So okay, let me run. Okay. 1 minus 1. With the right side. Eh, it's R plus L. Why is it R minus L? Because the index doesn't change. Oh my God. Oh my God. So this is very crucial. Let me just write down another note. Middle is R plus L divided by 2. Indexes are always 0. Okay. Okay, fourth one. Two item array rotated once. Okay, so at this point, I need to check the oh, point deflection or point index. Oh, okay, let's see. Oh dear. Let me add this test case. The index is 0. So the deflection point is at 0. Eh? Wait, let me do this. Oh shit. And then I do a min switch min and a console.log. So in this case, minimum is 1, right? The deflection point should be a 1. Oh, not a number. So, let's see. We'll do 0. Okay, so this one is a question that the number can be up to. So we just do, if it's not there, then we'll just do 1001 and 1001. So if I run this, oh, okay. So this one must account for length 2. So I'm gonna submit and gonna fail again. All right, the eighth test case is wrong. So the deflection point is at index 1. Mhm. And we use this test case. We run. So my minimum is 3. Why? Left, middle, right. Eh? Why did I include the left and right? Oh, oh no. Wait, this is my bad. I completely forgot. I don't know how I passed so many test cases. So middle index is equals to math dot norm L plus R divided by 2. Then you'll find the deflection point of so deflection left side is sorted. So I will find the right side. Nums. Then I'll find the right side, which is middle index, right index. So I'll just put a +1. Then I'll do nums, length index, middle index -1. So this is my bad. Really my bad. Okay, hold up. Let me use this test case again. So, oh, I'm really destroying this question. Okay, 3, 1. Target is 1. Actually, you know what? Why do I always have to care about that? I'll just find it. So, if I'm just gonna add uh or dot length equals to, okay, I'm not even gonna care about this line. Okay, so if nums dot length is equals to 2, then I'll check nums 0 equals to target, then you return to 0. Else we do nums 1 equals to target, then we return 1, else minus 1. 1 else minus 1. Oh, actually cleared so many 2 cases on. Okay, so this one is completely sorted. The deflection point is 1. Deflection point index is 1. This is wrong. Deflection point index is not 1. So let me just console log min. Min in. Oh, should use this test case. We'll run. Then min is 3. So we'll do left L, middle L, right L. Probably some undefined. Yeah. So left and right undefined. So let me instead check what is the middle log middle index. Middle index should be 1, right? So should be, oh my god, middle index minus 1. Middle index greater than 0. Yeah, correct. This is correct. Oh my god. Okay, I'm almost there. I'm almost there. Last part. So 513, target is 5. The deflection point is at index 1. So this is correct. So index point is at 1. Expected output is at 0. So the binary search. So okay. So largest. So let me just check. Console.log largest. Right, let's just run. Oh, largest is 5. Okay, that's good. So if largest is greater, is less than target, then we cannot find. So now the leftmost is 0, is 5 or so. Then if target so if let's say largest is the number that you want, right? Target is equals to largest. So then we have to add another case. If largest is equal to target, the current run reflection point index minus 1. So if I run this, it should pass, and then I submit, and I'm left with a few more test cases. So this one, my deflection point is 0, which is wrong. Deflection point should be 1. So the key takeaway, Middle is equals to L plus R divided by 2. Target is 1. So 5 divided by 2 is 2. So index 2. So if it's sorted 1, 2, 3, I need to check. So if it's sorted, right? Left element. Huh? What am I doing? So 1, 2, 3 is sorted. Wait a minute, this is wrong. Left will always be smaller than equal because it's sorted. If it is, okay, let's take a look at the hint just now. So I think it's this one. What the hell? How do I pass so many test cases? It is faulty as bug. Okay. If left, middle, right is sorted, so it's like in this case 1, 2, 3. I need to check the leftmost. So if the leftmost is bigger, right, it means it's the rotation is on the left. Yeah. So those move L is equals to nums L, right? So it's this leftmost L. So if I use this test case, and run it. Oh, I done. Holy. Well, the memory is not the best, but I think because there's a lot of console logs. So if I remove this, submit again. Holy. Okay, so I'm not even going to go too deep into the question, but the time complexity is log n and the space complexity is O1. So let's just do a quick run through of this before I go crazy. This is sorted, is always paired with rotated arrays. So this is where you find the deflection point. So a few key takeaways from the deflection point. First one, the middle index, right? It's not R minus L divided by 2, it's L plus R divided by 2 because indexes go from 0 to the highest number. So if you do a minus, there's a chance that the number gets smaller and smaller, and you always be in the first half of the array. Yeah. So left index, we'll have to check. Okay, so this one as well. Middle index just needs to be bigger. Just needs more than 0 to minus 1. So this one is okay. So this one is because you need it to be smaller than nums length minus 1, which is the last element, so that you can plus 1 to it. Okay, so I think you can just simplify this to like this. I submit it again, should work. Oh, never mind. Okay, let me just try it. Yeah, okay. So middle, another learning point. Middle plus 1 needs to be smaller than arm's length minus 1. Right. So if it's already the last element or something, if it's the only element, then yeah, you know what? Let me just remove it and see what test cases fail. Yeah, so in this case, so middle plus 1 must be so that you can add 1 to it. So that you can add 1 to it. Okay. Then for left element, we just get the 3 elements. So in this case, right, to check if it's sorted, if it is sorted, right, If it's not sorted, the deflection point is just the minimum index, the index representing the minimum element. But in the event it's sorted, we need to take the leftmost element, nums L, and then we'll check. Is leftmost element smaller than middle element? Right. So in this case, if let's say I look at test cases, 5 is bigger than 2. So that means there is a mismatch. There is not a sorted order. We will go to the left side to find. Else we'll go to the right side to find. Okay, this is still a binary search. And then now that we have the deflection point index, we will do nums. Okay, so this is a typical binary search. We do middle is r plus l divided by 2. And then if nums middle equals target, we just return the middle index. And then if there comes a point in time where L is bigger than or equals to R, there's nothing more to search and you can't find it, we just return -1. Then in the event that nums middle is bigger than target, we will do nums search from left to middle -1 and target, because middle is not, so you don't need to include it. Then if it's not, we'll just do nums middle plus 1. So no need to particularly ignore the covered above. Okay, so now the point is with the pseudocode is pretty simple. So pseudocode, find deflection point, split it down the smallest number, and then do normal binary search. I mean, a very trivial way would just be to use trivial is just like nums dot find index of target. So in the event actually I want to do search to, I just do like search nums target. I just do return nums dot find index. Target. So we just do n equals to target. So we just run submit. I don't even know what's the time complexity. Oh, this is the same. It's the exact same time complexity. Oh my days. So basically this is trivial. Trivial. And then I'm just going to use this. This is fun. So this is trivial. So just do. So I believe if this is how this is useful, because so use same execution time. Okay, so the key takeaway is that middle is equals to L plus R divided by 2, not R minus L. Then binary search off by 1 on both sides. So it's just basically this one, causing maximum cause that overflow. Nums dot length is equal to 1 or equal to 2. Handle hardcode, put to handle. And then rotated nums dot length times, get back the same sorted, just do binary search on the plane array. Yeah, so that's it. Everything is binary, binary, binary. So the timing is all log n, which is why the runtime is so fast. And yeah, that's it.